Friends, good morning. Today's subject of discussion is the synthesis of alprazolam. So, alprazolam is a benzodiazepine containing compound. It has the benzodiazepine ring as its basic ring molecule, to which is fused with triazole ring system. It is triazolobenzodiazepine. We can break this molecule over here. This will be PHCPH. This can act as one of the synthons, and I can break over here a 2 carbon donor. I can break over here a nitrogen donor, and I can break over here a 2 nitrogen donor, and I will get a 2 carbon donors. If I join all these pieces together, I can synthesize alprazolam. Before going to that, we can look into the utility of alprazolam. This is a potent tranquilizer which is fast acting and have moderate duration of action. And as we know, it belongs to triazolobenzodiazepine group of compounds. This has been utilized to treat anxiety disorders and panic disorders. Alprazolam was invented by Jackson Hester Jr. at Upjohn Company, and they patented this molecule for its treatment in the year 1971, and it got approved by FDA to use in US for medicinal purpose in the year 1981. Now, the diphenyl group, if I take here, I have taken a benzophenone derivative. There I need one nitrogen, and here I have PHC double bond. That's why here I have attached PHCO, and here the N is represented by amino group, and here chloro as such. 2 amino 5 chloro benzophenone can act as a starting material, and I have to treat with a 2 carbon donor. Alpha bromoacetobromide can act as a 2 carbon donor. There is lone pair of electrons on the nitrogen of the amino group attached to the benzene ring system, and the carbonyl carbon is the positive center as it is flanked between 2 electron withdrawing groups oxygen and bromine, which renders this carbon electron deficient, and this electron deficient carbon and this electron rich nitrogen, when we heat it, the reaction occurs between this electron deficient center and the electron rich center. It has to maintain its tetravalency as the bond is formed between the CN, excess bond is formed, and that's why bromine, being an easy leaving group, it kicks off bromide ion H plus and Br minus loses as HBr, and I get corresponding bromoacetamido derivative. Now I have to add a 1 nitrogen over here, and that nitrogen which I add should combine with this side chain attached to the amino group on the adjacent carbon. For this, I treat with ammonia. The lone pair of electrons on the nitrogen of the ammonia attacks on the carbonyl owing to its electro deficiency, which can be attributed to the electronegativity of the oxygen which is present adjacent to the carbon. Once the extra bond is formed, it has to maintain tetravalency. That's why pi electrons kicks off onto the oxygen and this becomes OH. I have got amino group attached to the carbonyl carbon and this carbonyl group it has got converted into alcoholic group. The lone pair of electrons on this nitrogen attacks on this electron deficient carbon. This electron deficient because it is flanked between two electron withdrawing groups carbonyl and bromide. It attacks on this positive center and it kicks off the bromide ion as it is an easy leaving group. It loses as HBr and it gives rise to corresponding diazepinone ring constructed over the phenyl ring system. I have synthesized benzodiazepine. The nitrogen hydrogen bond breaks and it forms bond with the adjacent carbon and OH gets kicked off. It loses as H2O and this undergo tautomerism. The bond between the nitrogen and hydrogen combines with the carbonyl carbon and the pi electrons moves onto the oxygen and O minus combines with H plus and I'll get corresponding hydroxy derivative of the benzodiazepine molecule. This OH I replace with chlorine by treating with a chlorinating agent like thionyl chloride. The chloro gets attached onto the carbon by replacing the OH. I'll get corresponding chloro derivative. This chloro derivative I treat with a 2 nitrogen donor that is hydrazine. The lone pair of electrons on the nitrogen attacks on the carbon which is electron deficient as it is flanked between two electron withdrawing groups nitrogen and chlorine. And chlorine gets kicked off as HCl and I'll get corresponding hydrazino derivative of benzodiazepine. I have to treat with a 2 carbon donor. The 2 carbon donor which we can take here is acetyl chloride. This has a positive center, an electron deficient center that is as flanked between two electron withdrawing group which renders this carbon electron deficient. This is electron rich nitrogen. It attacks on the carbonyl carbon. Chlorine being the easy leaving group loses as chloride which combines with H plus and it loses as HCl and I get corresponding acetamido derivative. This further upon heating, the pi electrons over here moves towards the nitrogen. It becomes N minus which is electron rich and that's why it is unstable. Thus way to regain its stability, the pi electrons are shared with the carbonyl carbon, the electron deficient center and it has to maintain its tetravalency. That's why pi electrons on the carbonyl carbon moves towards the oxygen and it becomes OH. A triazole ring has got constructed. This undergo dehydration. These electrons are utilized to form the bond with the adjacent carbon and it has to maintain its tetravalency. OH minus gets kicked off. H plus and OH minus combine together to lose as water molecule. And the nitrogen hydrogen bond breaks over here to satisfy the positive center over here. These electrons are utilized and the bond between the carbon and nitrogen is formed and it gives rise to triazolobenzodiazepine, the alprazolam. We have achieved the synthesis of alprazolam by following the route mentioned here. And next class we can deal with another class of drugs containing heterocyclic molecule. Till then, have a nice day. Thank you.